Today we're going to restore and explore IBM's massive PS2 tower. The Model 80 was one of the machines that came out during PS2's release year of 1987. It predates the tower standard, so compared to later clones, it's quite skinny, very tall and extremely heavy. PS2 stuff is pretty hard to find nowadays. It took me about 4 years to collect enough parts for this project. I have never turned this machine on, because we need to check for exploding caps inside first. This machine is badged IBM Personal System 2 Model 8386. The sticker all the way up here says 8550 A16, so this is one of the high-end machines. It came without the two covers for the diskette drives, but I found a couple of these about 3 years ago. My first IBM PS2 back in the day had a red switch. But unfortunately, this machine has a white switch. To me, an IBM PS2 absolutely has to have a red switch, so we're going to replace it later. To get inside, we need to remove the side panel that is held in place with these two huge screws on the side. Now we can just pull the side panel off and remove it. And here's the first issue with any Model 80. These machines are filled up with decomposed foam. This stuff is so nasty, it's extremely sticky and absolutely disgusting, and also really hard to clean up. And that stuff is everywhere inside this machine. This is the only thing I don't like about the Model 80. Otherwise, this is an awesome machine. This is how the machine came. There are no cards installed, there are no hard drives. But we do have two diskette drives. They are probably broken, so we are most likely going to repair them today. We do have one RAM card too. I'll talk more about the specs and details later in the video. But let's start with a complete disassembly. Let's start by pulling the front panel off. And it's held in place with plastic tabs. As far as I know, no PS2s have fragile plastics. Apparently I forgot to pull the battery. I have yet to see one of these leak. They probably do, but at least it's not a common thing. It's fairly risk-free to buy one of these, because the battery sits quite far from the motherboard. So if it would start to leak, it's not likely to destroy the machine. The front panel has a large insert that can be removed. With the insert removed, we can install two 5¼ drives. I am planning to install a CD-ROM drive in this machine, and maybe a floppy drive. I have not decided quite yet. Not sure about this date code here, but I think it could be the 31st week of 1991. These drives are not identical, so at least one of them has been replaced. It's quite possible that I have sourced and installed one of these drives. Perhaps it only came with one drive, I don't quite remember. Next we have this massive power supply. This thing is absolutely huge. It seems to be held in place with 4 large bolt head screws. To get access to this huge power connector, I think we need to remove the RAM card. RAM chips are IBM branded and dated week 41 of 1989. Now let's see if we can remove this huge power connector. How about that? It's actually quite similar to the Commodore PC-10 connector, but it's about twice the size. The power supply then has a large carrying handle here, so we can pull that thing out. Wow, that thing is massive! It's an international power supply, manufactured by some company called Schrack. Never heard of those guys. It also has modular Molex. So, if you think that's a new thing, IBM was doing this in 1987. It also has this massive cooling fan. So, if we're lucky, it's not a very noisy power supply. The drive cage is designed to take two 5¼ full-height drives. Or it can be used to take 4 half-height drives, with an optional bracket. Unfortunately, it's missing 2 of the screws here. So someone has been messing around with this machine before me. And kept 2 of the screws. With the screws removed, we can pull the entire cage out. It's also held in place with 2 tabs at the back of the case. And here's some of that black goo. This is nothing compared to what's coming. Let's see if it will come off with some IPA. Well, not easily. This is going to take a lot of scrubbing. We removed some of this stuff in a Model 70 restoration video. Let's try with some denatured alcohol. No, that didn't help much. I think we pretty much have to scrape that stuff off. I know I'm whining, but I hate this stuff. It's disgusting and really hard to get off. Let's see if we can remove the ribbon cable to the floppy drives next. It seems to be held in place with 2 plastic clips, 1 on each side of the connector. It does require quite a bit of force to remove, so maybe I should leave it in. I don't want to break these plastic clips off. There are also what looks like 2 plastic latches here. On other PS2 systems I have worked on, diskette drives are removed by pushing on this plastic tab. But in this machine it still seems to be stuck. So maybe we need to push on this plastic tab at the back too. Yeah, I think that did the trick. So let's try the same trick with this drive. Yep. This drive cage is missing 1 of the screws too. That's too bad. Even screws are hard to find for these machines. Next we have the speaker. Can't quite see how it's held in place. Oh, it isn't. It's just pushed in and can easily be pulled out. It does have 1 loose cable here. Don't know what it's for. Next we have the massive motherboard. This system is quite similar to the Model 70, but they don't share motherboards. This is a Type 3 board, by the way. I'll talk more about this later. I want to do all the cleaning first. All but 1 slot cover is missing. So this machine probably had 7 cards installed at some point. I think we need to remove this screw too, before we remove the motherboard. Okay, I think we can remove the motherboard now. Wow, that thing is huge. For a size comparison, here is a regular 486 board. This PS2 board is more than twice the size. This board is actually really clean. There is a tiny amount of dust up here, close to the fan, but otherwise this board is clean. So I'm actually not going to wash this board. It's kind of pointless. I'll just clean this dust off and save me the time. Last thing to come off are these large flip out feet. They definitely need a wash. I'm watching my preview screen here, and this massive case doesn't look all that big on camera. So let's do another size comparison. Here is a modern MSI board. I could probably fill this case with about 25 of these boards. The last thing we need to do before we wash the case is to remove this nasty foam pad. Most of this stuff is actually on the lid. So this is the only piece inside the actual case. This was actually a very nice surprise. This piece here has not gone sticky yet, but it is decomposed. Just by touching this stuff, it turns into dust. But I'm really glad at least this piece isn't sticky. Well, I'm gonna clean this off camera. The double-sided sticky tape is at least coming off partially. Okay, I think I found a decent method to remove this stuff. I'm pouring denatured alcohol all over this glue here, and after about 30 seconds I can scrape this stuff off. So this is actually not too bad. Yeah, this is definitely working. At least on this piece here. Okay, let's have a look inside that huge power supply and see if it has any refuzz. But first, one more size comparison. Here's a regular AT power supply. It looks absolutely tiny compared to this power supply. So this power supply is put together with security screws. These are T10 with a tiny little hole and a corresponding peg on the screw. And the usual disclaimer, of course, please don't mess around inside power supplies. They may contain high voltages, even with the cord unplugged. That being said, this power supply has probably not been turned on in a decade, maybe two. So all the caps are of course discharged inside. This power supply is sealed with a sticker here. So at least no one has been inside here and messed around. That is always a good thing. I think I got all the screws out. And yet it's still stuck in something. Okay, so apparently this piece here is the lid. And the PCB is screwed down to this part here. Well, in that case, I think we need to remove this screw too. It seems to be holding a ground cable. Here comes the lid. Wow, what a strange design. It has these really thick cables going all over the board. And it even has security screws inside the power supply. And the PCB is also soldered to the chassis here. So we need to desolder 2 ground cables here, just to get the PCB off. The Molex connectors are soldered to the PCB, so we need to remove them from the chassis. This power supply was clearly not designed to be serviced, but that's not going to stop us. At the back it has this large can with the IC connector, so we need to remove a couple of more screws, because the IC connector is soldered to the PCB. Well, at least the fan cable seems to have connectors. Okay, I think that's enough to tilt the lid off. Well, that fan definitely needs some cleaning. What the heck is that stuff? It looks disgusting. Okay, this is looking pretty good. There are no refas. These 2 guys are some other brand. There is some spider web inside here though. And then we have this mystery can here. I'll see if we can have a look inside. Let's try to bend these tabs and see if the lid will come off. I'm pretty sure there are some filter caps inside here. And I want to make sure they are not Rifa or Vima branded. These are definitely not designed to be taken apart. But someone has to find out what's inside here. This entire can here could be replaced with a regular IC connector if needed. But then we will lose whatever filtering is going on here. Okay, all the tabs have been unbent. Let's see if we can pry this can apart. Okay, I skipped ahead here. This took a while. But I think we're inside now. The things we do to avoid smelly refas. Okay, well, inside this can there is another can. But I think this lid comes off very easily. Yeah, as I thought, we have a safety cap and a coil. But luckily, that is not a Rifa. So this power supply is safe to turn on. So I'm going to go ahead and wash it and we'll try it out. The last thing we need to do before the wash is to take these drives apart. These drives is the most common fault on pretty much any IBM PS2. Oh wow, the worst drive I have seen so far. I'll show you in a minute what the problem is. Let's remove this rail here first. I can already tell you this is definitely not a working drive. So if you inspect one of these drives, you will almost always find 3 leaky caps underneath the drive. If you take a look at this pad here, you can clearly see it's corroded. So this drive is not an exception. However, this drive here also has some leaky caps on the upper PCB. So all 3 of these are leaking, and there are 2 more on this side here. And I can see quite a few corroded pads on nearby components. And now to the good part. The corrosion is quite mild, so I think this drive is still repairable. This is, by the way, a Mitsubishi drive. It's manufactured in 1988. And here is the part number. The other drive is an Alps. We have restored quite a few of these on the channel in previous projects. So far we have been able to repair them all. This drive has damaged screws, and one of the screws has been drilled out. So unfortunately someone has been inside here and messed around. I hope it didn't damage anything beyond repair, but who knows, maybe he fixed it. Let's pull that lid off and have a look inside. The upper head here is supposed to have a foam pad, and it's very often missing. This is a very common issue with these drives. If we're lucky, we will find it inside the drive. Well, hang on a minute, this is strange. This screw here is glued, so maybe this PCB hasn't been removed. Yeah, that glue came off now. So, whoever was inside here didn't go as far as to remove this PCB here. Before we remove this PCB here, a word of warning. Some of the early drives have a very fragile flat flex cable going to these heads. If you sneeze, that damn thing will break. So check before you remove this PCB. In this case here, this is a slightly later drive with regular cables. So we can just pull this PCB off. But first we need to remove these connectors. Same thing with these connectors here. I have yet to see these caps leak, so I'm going to leave this PCB as it is. Next we can remove this shield here. Unfortunately that pad is gone. Probably fell out through the front here. I'm not sure if this pad is strictly needed. I think one of my PS2s is missing that pad too. And if I remember correctly, it still works. But if needed, we can probably easily make one. It consists of two parts. One square metal piece here, and then a small foam pad glued on top. That should be easy to make. But before I wash this drive, let's check the caps. These Alps drives are a bit more tricky to disassemble. So first we need to remove these rails. And then we need to remove these screws here. They have been locked with some glue too. So the previous owner only removed the lid, maybe to remove that loose pad. I wish he left it in the machine. Okay, the next step is to pull the drive back and then lift the drive up and push it out through the front of the cage. A bit tricky with a large camera on top of the drive. You will find loose spring inside. It belongs inside the eject button here. If we turn the drive around to inspect the lower PCB, we're going to damage the heads here. So you need to use something that will keep the heads off the bench. Well, that's a rare sight. These caps are actually not leaking. I have been through quite a few of these drives, but this is a first. We are going to replace them anyways, of course, since they are known to go bad. So these two guys are 1 microfarad, 50 volts. This guy here is a 10 microfarad, 16 volts. Now to the worst part of a Model 80 restoration. The nasty black goo. I'm gonna wear gloves for this, because this stuff is really sticky. If you get this goo on your hands, it's really hard to get off. So I'm gonna scrape off what's left of the foam pad first. Yuck. And then we'll try with IPA and denatured alcohol. Let's try with a smaller piece here. Oh, that is so disgusting. I know I'm whining, but you probably would too, if you had to remove this gunk here. Well, disgusting or not, I think it's totally worth it. These machines are awesome. Definitely one of my favorite PS2s. After my Commodore years back in the 80s. My first Wintel PC was a PS2 Model 50. But this machine here should be quite a bit faster. Well, it's 25 megahertz, 386. This should actually be a pretty decent DOS gamer. Well, at least for adventure games. If you want to play Doom, 486 is a better choice. And now to the air ducts. I have never seen foam come apart like this in any other machine. So this must be some kind of special foam pad. I'm not even sure what it's for. I guess it's to lower the noise in the machine. But it only has like a few pieces inside. So I'm not sure if it actually makes a big difference. I'm not going to reinstall a new foam pad. Well, unless this machine turns out to be very noisy. Well, perhaps. With two full-height SCSI drives. I guess maybe these machines were extremely noisy. Maybe that's why they installed this foam pad. I'm not sure how to describe this stuff. It's sort of like fresh glue that has started to dry. Okay, I scraped off all the foam. Now let's see if we can remove the glue that's left with some IPA. I'm not sure if that green piece is double-sided tape. Well, it's hard to tell. But I think this green stuff here is glue. And the black stuff is what's left of the foam pad. Let's try with some denatured alcohol. The benefit with this stuff here is that it doesn't dry up as quickly as IPA. So I'm going to leave it like this for at least half a minute and see if it dissolves. Okay, let's try again. Yeah, this stuff works a lot better than IPA actually. That was definitely a good choice. So now that green pad is coming off too. Whatever it is. Yeah, this totally works. This is much better than IPA. Okay, I reapplied once more. And scrape some more. And now that stuff is pretty much gone. So there you have it. Apparently this is the method to get rid of that nasty stuff. I'll use the same method on the rest off camera. Okay, I'm making some progress here. I've been scraping this stuff off for about half an hour. I have to say, this is by far the most disgusting and annoying thing I have ever done with any vintage computer. Look at this slime. Wow. It doesn't get worse than this when it comes to restorations. Okay, all the bits and pieces are washed and left to dry. Let's start fixing stuff. Unfortunately, I ran into a problem pretty much immediately with the front covers for the diskette drives. IBM PS2 covers are not all identical. In fact, there are quite a few different covers. So this one here is for the Model 50 and Model 70. And as you can see, it's quite a bit smaller than the covers for the Model 80. So we can't use these. This Model 80 came with two different drives. So I thought I'd swap them for two of these Alps drives. But they are using the front cover with a large hole for the eject button. And unfortunately I can only find one of these in my stash. So that won't work either. The only two identical covers I have for the Model 80 have this much smaller hole for the eject button. So we can't use this drive either. So I'm gonna have to swap one or two of the drives. So we can use these bezels instead. I did manage to find two of those drives. They have now been washed and left to dry. But while we wait, I noticed something here with these bezels. PS2 stuff rarely go yellow, but at least this cover here is actually slightly yellow. So I'm gonna leave it in peroxide for half an hour. We'll see if it matches the front panel. It probably doesn't show too well on camera, because the camera tends to overexpose everything beige. But this cover matches quite well. This one not so much. Okay, let's take a quick look at the motherboard before we start testing stuff. There were 3 types of boards for the Model 80. The main difference is that the Type 1 boards were running at 16 MHz. Type 2 boards were running at 20 MHz. And these Type 3 boards are running at 25 MHz. And also have some cache on the motherboard. So right in the middle of the board we have a 386DX25. There are other differences too between the boards. If you want all the details, I highly recommend Arden Tools. Now let's move on and start doing some tests. Okay, power supply reassembled and connected to the board. Fingers crossed. Yes, it's posting. And we are getting error 211. I think that's a memory error. So that's a great start. I think these are 4 meg modules. Let's find out. Yes, it's counting up the RAM. We've got 1 meg, we've got 2 meg, 3 megs, and 4 megs. So my guess is right. I think I read somewhere that the Type 3 board can actually only use 4 meg modules. Now we're getting a 301 error. A 601, 161, 163, and beep codes, and now we're in basic. Awesome, so this board seems to be working, and the power supply too. We also have a working memory module. So the next step is to fix up the drives. I did some reading, and unfortunately I think this is the wrong drive cage for this machine. This drive cage is for the Type 1 or Type 2 machines, at least from what I could read online. And instead, this machine should use this drive cage here. They are pretty much identical. Main difference here is the backplane for the card edge connectors on the floppy drives. That also means that the drives I intended to use with this machine are incorrect for this Type 3 board. Well, luckily, I think I have 2 drives that will work. Only problem is, these are intended for another video, so I guess I have to source at least 1 more of these for a future video. Instead of card edge connectors and this backplane here, these drives are using a sort of standard looking cable. I'm not 100% sure about this information, so I'm going to double check, because these drives are really hard to find. And I honestly don't mind using drives with card edge connectors and this cage instead. But since we only have 1 front panel for this drive cage here, let's see if we can fix these 2 drives and use them at least for now. I can always replace them later. Okay, so these drives are washed, so if they have leaky caps, the electrolyte should now be gone. And this is a YE data drive, manufactured in 1990. I can see 2 caps down here. These are through holes, so not likely to leak. So this might be a working drive. Let's just go ahead and test it. The other drive is an Alps. And this drive here definitely has some leaky caps on the lower PCB. And same thing on this PCB here. You can clearly see some corrosion on these pads here and on these chip legs. So this drive needs to be fixed. I did not prepare for this recap, so I hope I have the correct caps in my stash. So let's remove a few screws and get that PCB off. Before we remove the PCB, we need to disconnect this flat flex here. And then we have a small ribbon cable down here. And a third connector here for the stepper. Okay, so now I think we can flip the PCB and have a look underneath. Yeah, definitely leaky caps here. So these are 10 microfarad, 16 volts. All 4 of these. And 1 more in the corner down here. We've got corrosion on the chip legs here. And on several components in this area here. So let's see if we can save this drive. Okay, we are lucky. I found all the caps needed for this drive. I'll start by adding flux to all the pads. Oh, this is gonna be tough. This guy here is covered up by this resistor here. So we're gonna have to remove this resistor to be able to replace this cap. So let's remove that resistor first. Let's make sure those legs are loose and not bent. There's our resistor. So first I use good flux and see if I can make that damaged solder melt. Yeah, that took a while, but it finally melted. Next I use some chip quick and place a large blob on the pad. Same thing on this side of the cap. I use good flux and I reapply if needed until I can make that solder melt. And then I add some chip quick. With the chip quick on the pads, just heat both pads up and the cap pops right off the board. I'll use the same method on all the caps on this board and skip ahead here. For this job, by the way, I use this tip here with a small flat surface. I only removed the 10 microfarad 16 volt caps first, not to mix things up. So now we need to remove all the chip quick. That is easily done with good flux and solder wick. Pads are quite heavily corroded, so I'm going to reapply flux until I get all those pads nice and shiny again. Wow, this PCB is really crusty, but I think we caught it on time. A few more years and these pads would have been gone. Before I put new caps on, I'm going to clean up the legs of the chip here and these pads here. I just use flux and a tiny splash of solder on the tip. And then I double check and make sure I don't have any bridges on these legs. Oh no, this chip leg here just came right off. Oh, that sucks. These stupid caps are killing our drives. That stuff is corrosive, so if left for long enough, it will kill all the components surrounding it. Okay, I checked and there are plenty of these chips on eBay. So this drive is still fixable. I'll clean up the flux before I replace those caps. So if you have a PS2 with drives that haven't been recapped yet, now is a good time to recap that drive. It's only gonna get worse. This drive is lucky. The component seems to be standard and easy to find. But some old components are impossible to find. I'm definitely not leaving this drive with old caps on the board. We might as well replace them right away. Oh crap, I just noticed these guys here are bipolar. You can tell because they're not marked with polarity like this cap here. So I'm gonna have to order some new caps and a new chip for this drive. And this drive is going to return in some other video in the future. I am of course not going to leave these caps in. I'll remove them right away. Now check out the legs of this chip here. That is corrosion too. So I'm actually going to take a few hours this weekend and just go through all my PS2 drives and remove all the caps. Because as I mentioned earlier in this video, sometimes it takes years before I have all the parts for a project. So those drives are sitting ducks. By the time I'm ready to record some of my videos, those drives are going to be dead. Well, this project isn't exactly going to plan, but in a way I'm glad this happened, because now we know this is the last chance to save IBM PS2 drives. Now let's test the first drive. To access the BIOS on the motherboard, you need to download a reference disk. You can find a copy on Arden Tools. I'm also going to install a battery for this test. This is the drive that had through-hole caps. Okay, it's counting up the RAM. And the disk drive woke up. Well, it tried to read, but then it just stopped. Huh. Well, let's try with a cleaning disk. Well, the drive is definitely spinning and the heads are moving. So let's try again. Let's hit F1. Okay, it's reading. Well, it makes some funny noises. But unfortunately, that drive is not okay. So, I'm gonna have to order some through-hole caps for this drive and fix it too. Well, in that case, let's try with a known good drive. With an edge connector. Now, let's see if we have better luck with this drive. Well, it's doing something. Okay, it works. Awesome. So either the other drive is bad too, or there might actually be some compatibility issue. Because this drive cage actually came with this motherboard. Someone may of course have replaced it. In here I'm gonna go to set features and set time and date. Just as a quick test before we reassemble the machine. I'm just gonna set it to a random date. And exit. Now let's check after a reboot. Yeah, it remembers the date, so this is totally working. Now let's see if it will boot to DOS. And it totally does. Awesome. So we have a working system, but we do have a problem here. That is one noisy fan. So that's what we need to take care of next. This is a 225 watt power supply. And I actually have an upgrade. This power supply here can do 250 watts. So let's do an upgrade. It has already been cleaned and checked for refuzz. I seriously doubt that I will ever need 250 watts in this machine. But since I have one, let's use it. It is untested though, so let's see if it works. Okay, fan spins up. And it posts. So that seems to be a working power supply. Yeah, boost to DOS. So that is definitely a working power supply. But it's roughly as noisy as the other power supply. That is too noisy for my tastes. Let's fix it. I'm gonna start by checking some of these large caps, since it was turned on just moments ago. I can't reach all the large caps, so I'm gonna be careful not touching this PCB. This power supply has a nice big brushless panel with some rather interesting blades. So I'm not going to replace it, but I am going to snip that cable off. Then I'm going to add an MP2307 step-down buck converter. Then I'm going to adjust it and slow that fan down just ever so slightly. By the way, don't do what I do. There is of course mains voltage present here. Yeah, I think that's perfect. To protect it, I'm going to use some heat shrink. While we're in here, let's do another mod. My first PS2 back in the day had a red power switch. For unknown reasons to me, IBM switched to white switches at some point. No pun intended. So white switches on PS2s always looked wrong to me. So the first thing I did when I bought the system years ago was to buy a red switch for it. It doesn't have part numbers on it, but it's stamped ProNIC, in case you're looking for one of these switches online. So let's switch back. Okay, so these switches are not identical, but I think the switch is similar enough so we can modify it to fit. There are a couple of ways we could do this. I think the easiest way is just to bend these pieces and drill new holes. Yeah, I think that's the easiest way. Let's try it. Okay, I managed to bend these tabs down like this. So now they are at the same level as the original switch. The important thing here is the rating. And at least according to the eBay listing, These are rated for mains. So the only thing we need to do now is to drill a couple of holes here. Okay, that was actually easier than I thought. Our next issue is that this switch here is wider than the original switch. Oh, I didn't notice this before. This switch is actually stamped and it's rated for 10 amps at 250 volt AC or 15 amps at 125 volts AC. So this switch should be safe to use here. The new switch doesn't have to be quite this narrow, but it's 1 or 2 millimeters too thick to fit inside the case. So I'm gonna grab the Dremel and use one of these and just cut a thin slice on both sides like this. Stupid battery in the camera died while I was cutting, but as you can see, this went really well. That looks great. That's more than good enough. And we now have a narrow red switch. Okay, I used the beeper and made sure it was wired in the same way as the original switch. I have soldered all the wires to the switch. Now it should be ready to install. And it looks like it fits. Actually, not quite. There isn't room enough for this piece here. So it has to go. Okay, now it fits perfectly. If anybody knows what the part numbers are for an original red switch, then please post below. I'm probably not the only one who thinks these power supplies should have red switches. To compensate for the slightly lower airflow, I'm going to install a second fan in the chassis, also running at a lower speed. So the total airflow is actually going to be slightly higher, with less noise from the power supply. Okay, we're almost ready for the reassembly, but there's one more thing we need to do. So I pull this tab off from the battery holder, and then I'm going to strip this wire, and then I'm going to put it back on. Oh, that was too difficult to get on camera. So I remove this wire here, strip the end of the wire, and then put it back on. So if we reinstall this now, we have this short extension of the cable. This way the system will work with the original battery, but now it can also take regular CR2032s. These are connected in series, so it's going to give us 6 volts. Okay, it's finally time for the reassembly. Everything is so nice and clean. I'm going to start with the flip out feet. We don't want the skinny tower to fall over. I'm not a big fan of flip out feet, but I should probably use them for this machine. Oh, I missed some of that gunk here, and it didn't come off in the wash. Okay, that's much better. Now we can install the motherboard. This large motherboard looks kind of normal in this huge case. I think these machines were sold as workstations, but they were not uncommon to find running as servers. Next we have 250 watts of power. The PS2 was sort of a new standard of PCs, so I'm a bit surprised that they didn't install the power supply at the bottom of the case, because it's so heavy. Okay, let's reinstall that massive power connector. This thing looks like it belongs in a truck and not in a PC. And then we have the RAM cards. They have tiny latches on the side here, so we can lock it in place. And I'm gonna install 2 of these. I think this is max for the motherboard, but it will take more RAM with expansion cards. On top of the motherboard we have that huge drive cage. I don't have one of the inserts to install 2 half-height drives instead of 1 full-height drive, so I'm kind of hoping someone will make 3D printed replicas.
That will be a really nice addition to this build. Next we have the drive cage for the diskette drives. Hopefully someone watching this who knows more about these machines can tell us whether this is the correct drive cage or not. Okay, now to the front panel. After 1 hour in peroxide, I can't really tell anymore which one is which. Apparently 1 hour was perfect to get that cover back to its original color. Unfortunately though, we can't use these, since we have to use a drive with a card edge connector. We're gonna have to use one of these with a larger hole for the eject button. And since I only have one of these, I'm gonna have to go with a blank for now. At least until I can find one more of these covers here. I'm gonna be nice to these tabs and add some PTFE just in case. If it slides in easily, these tabs are not likely to break. Oh, I almost forgot the diskette drive. Now we can put the front panel back on. Yeah, perhaps a bit silly, but that red switch looks so much better. It just looks right. I can't really tell that it's not an original switch. Yeah, that looks perfect. Nostalgia is a funny thing. I had a red switch back then, so I'm having one now too. Next we have the hard drive. The only hard drive I have that will fit and work in this machine is this Apple branded half-height 5¼ inch drive. It's only 40 megs, so it's way off the original specs of this machine. I'm not sure what the original drive was, but I think it was 120 or 320. So quite a bit larger than this drive here. The drive is locked in place with these large thumb screws. To be able to use that SCSI drive, we need a SCSI controller. I have washed this card, so that's why I removed all the EPROMs, because they have paper stickers. And paper stickers don't like soapy water. Card is nice and clean though. The dates on the chip on the motherboard are from week 11 of 1992. So that's roughly when this machine was made. And this EPROM here has 1992 written on it too. So it's a pretty good match. I haven't done my reading on the different MCA slots here, so we may have to rearrange all the cards later. But I'm gonna install the SCSI card in this slot here. Slots are very strangely labeled on this machine. So apparently this is slot 13. But this machine obviously doesn't have 13 slots. So that doesn't make much sense. I almost forgot the speaker. It's pretty poorly installed in this machine. It's just stuck in here. But it's not locked in place with any tabs. So if you bump into one of these machines, that speaker is gonna fall out. That's a bit strange. This whole assembly is actually quite messy. So I decided to add a couple of zip ties. And I'm gonna install the battery holder with some double-sided tape. Yeah, that's much better. Okay, I managed to squeeze in that very long SCSI cable underneath the drive. I'm pretty sure this is an original cable for the Model 80. So I don't understand why it's so long. Maybe I'm supposed to install the SCSI controller all the way down here. Who knows? Next we need some power for that hard drive. That shouldn't be a problem. We've got 250 watts here and a modular cable. There's also this ground cable here. I'm gonna assume it's designed to connect to the hard drive. Next we need to fix the airflow in this chassis. This power supply is a bit weird. It's sucking in air through the back and through this grill here on both sides. Then it's blowing the air onto the motherboard. That's very strange. So first I thought I had reinstalled the fan incorrectly, so I had to check. But this power supply is actually designed backwards. There are no vent holes at the back here, so we need to install the fan here. and push the air out through this grill here. And, well, I guess into my face. That's a pretty bad design. And now to the lucky part. The fan in the power supply is 12 centimeters, and so is the distance between the drive cage and the speaker here. So, if we install standard Noctua 12 centimeter fan, it gets perfectly jammed in here. Doesn't even need any screws. With the added benefit that this wonky speaker now sits firmly in the case too. I made a custom cable for it, with the buck converter installed inside. So it has been slowed down slightly too, just like the fan and the power supply. I'm gonna have to say it again, this is a very strange design. Imagine having 4 of these drives in the middle here, 2 drives up here, and a heavy power supply at the top, and no weight at all down here, in this very skinny form factor. I wonder how many of these fell over and died back in the day. Without those feet flipped out, it takes almost nothing to make this thing fall over. Oh, I thought it was too good to be true, and it is. I'm trying to install the lid, but there isn't enough room for the air duct and the installed fan here. So that's not gonna work, unfortunately. I need to come up with something else. Maybe we can install it here in the air duct. I'm gonna have to do some thinking. Well, I can't install it on this side either. Well, I guess that depends on how long my cards are. This is my longest card, so this should actually work. No. Still not enough room, so that won't work either. That kind of sucks, because the only way out for the air is through the front grill here. Well, in that case it has to be installed on the air ducts. But I don't want to drill any holes in any of the original parts. Okay, I checked. We can actually fit a skinny Noctua fan inside the front panel. Those fans are 15 millimeters, and the space here is actually 16 millimeters. So I think that's the best solution. I'll order a fan and we'll try it out in a future video. Well, I still have a huge pile of stuff to install in this machine. I'm gonna need another week to finish this project. If you're watching this in the future, there will be a link on the display shortly to part 2. If you're watching this fresh, hit the bell icon below and set it to all. If you haven't watched my video restoring the little brother of this machine, the Model 50, now is a good time to catch up. I will end by saying thank you to my patrons. I appreciate your support. If you want to support me too, consider becoming a patron. Patrons get ad-free early access. If you like this video, let me know with a thumbs up in the comments. If you're a regular viewer, consider subscribing to this channel. Thank you for watching, I'll see you next week.